I'm dedicating this lecture to my father. Good afternoon. My name is Harry Allen. My title is hip hop activist and media assassin. I've worked as a journalist covering popular culture with an emphasis on hip hop for nearly 40 years. I'm a 2026 MIT Dr. Martin Luther King Jr. visiting professor and scholar. I'm very honored to be hosted here at MIT by Dr. Brian Wardle. Brian is a full professor of aeronautics and astronautics at MIT with a joint appointment in mechanical engineering. I want to thank Megan for that very kind intro. My presentation is titled How to Build a Hip Hop Deep Space Monument, which I also abbreviate as HHDSM, so you'll hear me say that throughout the talk. Today, I'll explain what that is, talk about what inspired me to work on this project, and give you my best thinking about how to make such a thing. But before that, I'm going to tell you why I came to MIT. I'll discuss my project. I'll talk about being mentored as a part of the MLK program. I'll discuss formidable challenges to the Hip Hop Deep Space Monument. I'll talk about how I'm engaging with the MIT community and my research. Then I'll take your questions, comments, suggestions, or complaints. In a way, asking why I came to MIT reminds me of when master criminal Willie Sutton was asked why he robbed banks. Because, he said, that's where the money is. This story is widely deemed apocryphal, but the Massachusetts Institute of Technology's reputation is not. MIT is the best school for science, technology, engineering, and/or math in the universe. Further, MIT has been frequently ranked the best university for any course of study, period. My project, as you'll soon see, depends heavily on the skill sets that are brought and refined here, let alone those of the refiners. This is why I'm at MIT. However, I'm a Martin Luther King Jr. visiting professor and scholar because of, 1, the legacy and singular prophetic vision of Dr. Martin Luther King Jr. 2, a meeting I had at Harvard in 2017 with MIT CMSW professor Junot Diaz. The Pulitzer Prize winning author told me about the program and made an initial application on my behalf. The MIT Center for Art, Science, and Technology artist residency I did in 2020 is number 3. This came out of meeting Junot. It led to being hosted by MIT professor of the practice in music technology and Guitar Hero co-inventor Iran Ergozi, after a phone meeting with Iran and Evan Ziporin, director of CAST. It resulted in me forming Harbinger, my turntablist septet at MIT. Those influences and experiences all led to me petitioning Brian Wardle in my subsequent application to the Visiting Professors and Scholars, or MLK VPS program. Being an MLK visiting professor and scholar has equipped me with resources to work on a hard problem, one to which I could little give attention, let alone most of my time, outside of these walls. Meanwhile, inside of them are exchanges and economies of which I wanted to be a part and now am. The Hip Hop Deep Space Mission Monument, or HHDSM, is an effort to design, construct, and launch a deep space, deep time capsule hosted far beyond the Earth by a spacefaring vehicle. This capsule will bear a cache of analog sound recordings, 50 to 100 of them in total. These works will have been deemed through review and discussion with a broad convention of experts to represent hip-hop culture at its highest, most expressive, most definitive, and most essential level. These will be the recordings which most purely embody the spirit of hip hop, its meaning, and its creative peaks. One might say these are the recordings by which, if we held on to them as the world was lost, we might be able to start the culture over again. The plan is to, on a date in fall 2029, that year being the 50th anniversary of Rapper's Delight's release and the beginning of hip hop as a commercial form, this craft, a six-vaned solar sail project named Mandala, will be rocket boosted above the Earth's atmosphere. From there, the vehicle will detach, then, via a series of maneuvers over time, including a hybrid gas or gravity assist solar pressure trajectory, ultimately accelerate to high speed, ideally roughly 1/10,000th of c, or 1% of the speed of light, just under 20 miles a second. The craft's destination will be a relatively nearby extrasolar system, Gliese 667c. This is a red dwarf star, part of a trinary system located 23.6 light years from Earth in the constellation of Scorpius. The star is orbited by a planet in its habitable zone. This is a super Earth. After a travel period of at least 200 millennia, the spacecraft will enter the general vicinity of Gliese 667c. There, it may be intercepted by an intelligent space-capable species, should any exist around the star. Or it will pass, perhaps unnoticed, through this solar system, either traveling until a possible future encounter at a yet-to-be-determined place and time, or moving endlessly through space, possibly traversing the circumference of our Milky Way galaxy once every 3 billion or so years. Nothing in the above plan is impossible. None of it relies on yet to be invented materials, methods, or tools. It requires no warp drives, no unobtainium. However, all of it is extremely difficult, particularly for a homegrown effort. According to the United States Office for Outer Space Affairs, 20,344 objects as of 2024 have been launched into space since Russia's Sputnik in 1957, 11,969 from the United States. Of those, only 5 craft have left the solar system. All of these were flung toward distant stars by the mighty arm of NASA. All of them atop Herculean boosters armed with powerful radioisotope thermoelectric generators. Compared to them, I'm proposing flying a microlight through space, in formation with barnacle geese. This then was another reason to reach out to MIT. I felt seeding the project here would give it the highest opportunity for survival in some form. Certainly better than it would have had at my home office, between distractions of increasingly difficult freelancing and the pull of day-to-day life. So apart from applying to the MLK VPS program itself, my best call has been reaching out to Brian Wardle, or as I called him in my initial January 2025 email, the Carbon Whisperer. In my introductory note, I made 2 requests re-mentorship. I asked if he would help me come up with a material for the HHDSM's sound recordings. Then, sporting crazy nerve, I asked if he would nominate me to the MLK VPS program, the deadline of which was then 3 weeks away. Approaching Brian was kind of a Hail Mary pass. I'd not had any success finding someone to nominate my idea. Even though the suggestion to reach out to him came from someone highly placed at MIT, I'd become so despairing. I waited a month and a half before contacting him. This, with a looming deadline, I wasn't going to do it at all and get turned down again. I'm glad I somehow countered the negativity of my thinking and contacted him. And obviously, he said yes. But while reflecting on collaborating with this great scientist, what I've realized is this: good mentoring is kind of like good improv. In comedic improvisation, there's a key rule that when your partner does something, you respond with yes, and you don't wrinkle up your nose and say, huh? By affirming one's partner and building on whatever zaniness they put forward, both keep contributing and adding to the scene, building both its density and hilarity. I don't have a particularly deep notion or model of mentorship, even though the MLK VPS program is built on and structured around it, as is much here at MIT. What I can say, though, is Brian stays positive, affirming, and celebratory. He seems to understand how to gently steer mentees toward an objective without being obstinate. Early on, I said to him, "You haven't turned down or reacted negatively to anything I've proposed so far. It encourages me to keep bringing you ideas." We have weekly meetings at his request and have done so almost from the moment I came aboard. And he makes those meetings, even though he's very busy. When I have his time, I have his time. And I don't have to hunt for him or wonder when I'll see him next. Most importantly, Brian has been the key engine of my engagement here at MIT. The way he's putting me in front of other faculty and coming up with ways for me to interact with different layers of life at MIT has been tremendous. Immediately, once I was on board, he made sure I was part of his next lab study group and recruited a strong group of volunteers to support the HHDSM project. Da, 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 da. Meeting these gifted young engineers continues to be one of the best parts of my MIT experience thus far. As well, I've realized part of the reason for making sure I was part of the group was to expose me to how engineers think. There's a great story from one of my favorite books, Skunk Works, that the team, the Next Lab Hybrid HHDSM team, made me recall. Skunk Works is about the history of Lockheed's Advanced Development Programs division. Skunk Works is by Ben Rich, successor to the division's founder, Clarence Kelly Johnson. In the story, they're giving Have Blue a test flight. Have Blue is the code name for what will ultimately become the F-117 Nighthawk. That's the plane right there on the book's cover, the first one to be built around stealth technology. 72 hours before the first test flight, the airplane began to seriously overheat near the tail engine test runs. The engine was removed, and Bob Murphy and a helper decided to improvise by building a heat shield. They noticed a 6-foot steel shop tool cabinet. "Steel is steel," Murphy said to his assistants. "We'll send Ben Rich a bill for a new cabinet." They began cutting up the cabinet to make the heat shield panels between Have Blue's surface and its engine. And it worked perfectly, only in the Skunk Works. For me, the takeaway was engineers engineer. I guess that's why they're called engineers. Coming to MIT, I eliminated one of the challenges to the HHDSM project: being surrounded by people who don't get the idea or see how it's feasible. As I said to some colleagues, this is a place where when you say, "I want to build a time capsule that's going to leave Earth and then accelerate, do a gas maneuver around the sun, and go on through it," they just cock their heads and say, "Okay, well, what you need is..." It's extremely refreshing, I tell you. However, I've not eliminated all of my obstacles. 5 remain pressing on my mind as it pertains to this project. They are, number one, the incomprehensible enormity of the spatial void. One of the hardest things to convey or understand to most people, convey to most people or understand is how big space is. There is nothing any person experiences which in any way prepares one to truly reckon with this fact. The best way we may do so, perhaps, is by analogies. If there was a highway to the sun, if air-breathing engines worked in space, and if you could get on that highway to the sun and drive there going 60 miles an hour, never had to refuel, never got tired, just 60 miles an hour continuously, it would take you only 175 years to get there. If after the trip you said, I'm not going to drive home, I'm taking Concorde. Now, as an aside, Concorde never flew across the US, but had it done so, it would have gone from New York to LA in less than 2 hours. So that's how fast Concorde was. Now back to our story. You say, I'm taking Concorde, assuming nonstop travel. It would take you 8 years to get back to Earth. But if instead you said, wait a minute, I've got this fancy supersonic plane, I'm here in space with unlimited fuel, plus enough air, water, and food to last me forever, let's go to Neptune. Pronto. At top speed, you get there in just 2.5 centuries. Or take a look at this famous scene from 1980's Star Wars, The Empire Strikes Back. It's the asteroid chase scene.
You're not actually going into an asteroid field.
It'd be crazy to follow us, wouldn't they?
You didn't have to do this to impress me.
Sir, the possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
Never tell me the odds.
Still amazing. And the asteroid field escape is kind of a trope of science fiction. But in truth and in fact, in an asteroid belt, like the one between Mars and Jupiter in our solar system, these rocky bodies average about 600,000 miles apart. That's about 2.5 times the distance between Earth and the moon. So your chances of needing to dodge one or hit one are null to zero. This fact, the immense vastness of space, is the basis of almost everything having to do with projects that go there or want to. It's always at least a major factor. It also means that in space, there are no short trips. They're all just some variation of long. That's the first of the 5 problems. Number 2, the daunting technological complexity of the task, especially of calculating and executing orbits. To move in and around the solar system means negotiating falling. Kind of like the hallway fight scene from Inception. In other words, figuring out how to let the pull of gravity move you, plus when and how to resist it, so that it doesn't keep you down or suck you in. For example, one of the critical maneuvers of a transsolar flight via solar sail would be a gasp, again, gravity assist and solar pressure. And I should say, I'm very proud of this. I may have come up with this acronym here at MIT, so I'm very proud of that. But one of the most counterintuitive facts about space is how hard it is to fly toward the sun. The reason being that first, you must stop going 67,000 miles per hour past it, which is what we're all doing right now. It's the speed the Earth moves as it revolves around Sol and as we give it side-eye. Doing this means either throwing on rockets and burning valuable fuel in order to stop, or figuring out how to dance with the gravity of your fellow planets, but letting go at the right moment and angle so that you don't go into the sun. And this is complicated. Number 3, the cost of spaceflight. Space is increasingly becoming a business after decades of it being a geopolitical mandate. However, the absence thus far of a business or even a science reason for this project always nips at its heels, threatening at any moment to make it no more than a thought experiment. Number 4, scarcity of trans-solar role models. Again, only 5 craft have been directed on a trajectory out of the solar system: Pioneers 10 and 11, Voyagers 1 and 2, and New Horizons, which went past Pluto in 2015. And then number 5, the evasive finitude of time. This is Larry Zottarelli, a computer expert, hired at 40 to work on the Voyager project before it launched. He retired in 2015 at the age of 80. With his departure, the Register noted, quote, NASA is reportedly seeking a replacement fluent in Fortran, Algol, and assembly language for the Voyager's 250 kilohertz General Electric 18-bit TTL CPUs, complete with single register accumulator and bit serial access to 4096 word plated wire RAM. Now you laugh, I don't know what any of that means, but I suspect it's not a PlayStation 5. Time will eventually collect every one of us. But no matter how expertly such an outing is run, time will, with special glee, claim adherence to a trans-solar space mission. It will do so because these missions make highly unusual, audacious demands on time. Then, who will rewrite the Fortran? In fact, the fate of most time capsules is that they are lost or forgotten. And there's certainly nothing harder than trying to find something lost in space. As part of my engagement with the MIT community, I've worked on a number of activities thus far. I've visited classes with Brian, briefly talking to students about the HHDSM project and recruiting interested volunteers for our team. I gave a For Extra Points review of papers from Dr. Benita Camo's micro nano class. I conducted an interview with science journalist Laura Martin Agudelo's podcast. I met students in Richard Linares' class. One of his students, it seems, will be joining our HHDSM team, and Richard has decided to contribute and be a part of this as well, as much as his busy schedule allows, which is amazing. He's giving us great advice on the critical role of creating meaningful orbits. Yesterday, I and the HHDSM research group from Next Lab met with Maya Nasser of the famed MIT Humans Project. A few weeks ago, Zach Manchester of the provocative Breakthrough Starshot Project spoke to the HHDSM research group. That plan was to use ground-based lasers to speed postage size and bigger solar sailcraft up to 20% of the speed of light for a convoy headed toward Proxima Centauri, the nearest star to our sun at 4.24 light years. In the spring, I look forward to assembling a new lineup of scientists to meet with our group. There's a lot of activity and interest and theory, hypotheses, but also discussion about projects akin to the HHDSM. I also plan, or expect, I should say, to put together panels and other public events with themes connected to my efforts. Topics like deep time artworks, audiophile record mastering, and insights into the creation of hip-hop masterworks by a few of its great producers. Finally, in the fall, I'll be teaching a lab on listening to hip-hop and decoding its great works. The objective is to equip attendees with power to make knowledgeable selections of important records from hip hop's half century. The ultimate outcome will be a selection by the lab of one recording for inclusion in the time capsule, official inclusion in it. Now, I'd like to close my talk by addressing one question. Why do I call the craft I expect to build a monument? The answer has to do with the definition of the word given by Monument Lab. They're an Philadelphia-based nonprofit public art, history, and design studio. Recently, they performed a monument audit for the Mellon Foundation, tallying up monuments on display throughout the United States. Before doing so, however, they had to answer this question: what is a monument? In their report, they defined a monument as a statement of power and presence in public. I'll say that again, a statement of power and presence in public. As I grappled with the definition, I thought about the Voyager probes which embrace the golden record. I think many people know what the golden record is. If you don't, it is a compilation that was attached to both Voyager crafts, Voyager 1 and 2 in 1977, containing, as it said on the center label, the sounds of Earth. Greetings, music, natural sounds, literally a time capsule of Earth's audio for any beings that might one day find this craft as it makes its journey amongst the stars. I am very influenced by this, as you might imagine, and it still remains one of my most fond and greatest narratives and pieces of art. Well, anyway, I was thinking about it, and I was thinking about this definition, and I thought, well, first, there is nothing more public than outer space. Outer space seems to be the definition of public. Second, nothing states power and reveals presence like sweeping through billions of cosmic miles unimpeded. And then I concluded, Voyager 1 and Voyager 2 are monuments. And then this led me to think about my own project. I thought, we revere these craft because of the distances they have ably traveled. It is not just the craft which earns our high esteem, but the miles through which it has sped. Those miles and that space it leaves behind are as much a part of the object as a tail is of a tiger. In other words, we're one to think of it in terms of statuary. The craft is the sculpture, and the space behind it is the plinth.